Okay, yeah, this is just a continuation of 7.5, part 2. If 3 is a 0, then x minus 3 is a factor. If negative 8 is a 0, then x plus 8 is a factor. Okay? If 2 is a 0, then what's a factor? X minus 2. If 3i is a 0, then what's a factor? X minus 3i. If 3i is a 0, then, based on what I told you before, then there's another 0. And what is it? Negative 3i, right? Remember, if you have an imaginary root, its conjugate is also a 0 or a root. So if 3i is a root, then negative 3i is also a root. And if negative 3i is a 0, then what's a factor? X plus 3i. And so let's find this polynomial. Okay. Well, I'm going to multiply these two together first, okay, which are, what is that? What's the difference of two squares? X times x is x squared. X times 3i is 3ix minus 3ix in the middle. Cancel each other out. Negative 3i times a positive 3i is a negative 9i squared. And what is negative 9i squared? Plus 9. And now we use FOIL. X cubed plus 9x minus 2x squared minus 18. And that's my polynomial. And this is a polynomial where the zeros are going to be 2, 3i, and negative 3i. Okay? Well, let me ask this then. If I were to take this polynomial here and multiply everything by 3, would the zeros still be the same? Yes, they would. Right, they would still be the same. Okay. Did you have a question?
Yeah, where did you get the first two from?
Well, if 2 is a 0, then x minus 2 is a
Yeah,
factor.
how did you get that 0 from that equation?
From here?
Yeah.
If 3 is a 0, then x minus 3 is a factor. If negative 8 is a 0, then x plus 8 is a factor. Can I multiply these two together to get this?
Yeah.
Now the second problem.
Oh, it's a separate problem?
Yes.
Okay, that explains it.
Now you okay? All right. Yeah, if 2 is a 0, x minus 2 is a factor, and so on. All right. So there could be a number out here that we don't know, because it's still going to be the same zeros. So knowing that, let's take it to a problem like this. Give me a polynomial of degree 3, given that the zeros are 5, 2i, and also p of 0 equals 10. Okay. If 5 is a 0, then a factor would be x minus 5. Good. If 2i is a 0, then x minus 2i is a factor. And if 2i is a 0, then it has to be a negative 2i, is also a 0. So that would be x plus 2i. And there's my polynomial. But there could be a number out in front. Let's call that a. There could be a number out front, and it would still have those same zeros. So let's multiply the x minus 2i times x plus 2i. Using FOIL, x times x, outside and inside terms will cancel. Negative 2i times a positive 2i is a negative 4i squared, which is plus 4. And there's my polynomial. Okay? And let's distribute. I have x cubed plus 4x minus 5x squared minus 20 equals this polynomial. But I need to find out what a is. I'm going to rewrite, just to put in the parentheses, I want to put that in standard form. Don't have to, but now can somebody explain to me p of 0 equals 10? What does that mean? Read.
X equals 0, polynomial equals 10.
Right. So when x equals 0, this polynomial equals 10. Well, let's put in 0 for x. I have a 0 here, 0, 0, negative 20. We've done something like this before. Negative 20a equals 10. A would equal negative 1/2. Okay. So the polynomial with zeros at 5, 2i, and negative 2i, such that p of 0 equals 10 would be the negative 1/2 that we just found, because I'm going to put that in right here, times x cubed minus 5x squared plus 4x minus 20. Okay, makes sense? And that's the polynomial. The book will ask you to distribute the negative 1/2. I don't care. If you could get to this point, I'm happy with that. Yes, Michelle?
So the 1/2 applies to the entire polynomial?
Yes. Right. If I did distribute, it would be negative 1/2 x cubed plus 5/2 x squared minus 2x plus 10. Okay? That's what the book wants you to do, but I'm okay with just the top lines. Yes, hon?
I'm a little confused, like, why is there like negative 20 left in the parentheses?
Because if you put in a 0 for x here, what does that give you? And if you put, you're putting in 0 for each x. Okay?
Oh, so if it's p of 0 equals 10, then what is the parentheses by the p for the function, you plug it in where the x is?
That's correct.
Okay, that's nice.
And it'll always be 0.
Okay.
All right? So let's try this one. Give me a polynomial of degree 4. I'll need somebody to help me with this problem. I need a polynomial of degree 4. P is of degree 4. The zeros are at 3 with a multiplicity of 2, and 5 plus 3i. Those are the zeros. Michael, if 3 is a 0, can you tell me what a factor is?
X negative 3.
X minus 3. And what does that mean, Mike? Multiplicity of 2.
That you, that like, should it be like 2a negative 6?
No.
Minus 6?
No, it doesn't mean you multiply by 2. Kayla, do you know what that means, multiplicity of 2? Yes. It means that there's 2x minus 3s. When it says multiplicity of 2, it just means that there's 2 zeros at 3. Michael, when I graph that, I'm going to get a W shape, but it's just going to touch at 3 and then go right back up or right back down. Right? We talked about that before, didn't we? All right. If we have a 0 at 3, then x minus 3 is a factor. If we have a 0 at 5 plus 3, then a factor would be what, Mike? If 5 plus 3i is a 0, then what is a factor?
Negative 5, or minus 5 minus 3i. X minus
X,
5.
yeah, x minus 5 plus 3i. Would that make sense? Look, if 3 is a factor, if 3 is a 0, x minus 3 is a factor. If 5 plus 3i is a 0, then x minus that is a factor. And if 5 plus 3i is a 0, then what's another 0? 5 minus 3i. Perfect. It'd be x minus 5 minus 3i. Okay? Let's multiply that all out and then find out what a is. I know. X minus 3 times x minus 3 is x squared minus 6x plus 9. For here, x, I'm going to remove the inside parenthesis. X minus 5 minus 3i times x minus 5 plus 3i. I have x squared minus 6x plus 9. All right, x times x, x squared. X times negative 5, x times 3i, 3ix. I distributed the x. Now let's distribute the negative 5. Negative 5x, negative 5 times negative 5, and negative 5 times 3i. Then negative 3i times x, negative 3i times negative 5, plus 15i, and negative 3i times a positive 3i, negative 9i squared, which is negative 9i squared, which is 9 plus 9. Okay? Let's combine like terms. All right, I have x squared. I have negative 5x, negative 5x. Oh, that's negative 10x. 3ix minus 3ix cancel. Negative 15i plus 15i cancel. And I have the 25 plus 9 is 34. What's missing? The a. Let's find the a. Up top here, it says P of 0 is 1224. That means when I put in 0 for x, 0, 0, 9. 0, 0, 34. 9 times 34 is 306. A equals 1224. A equals 4. That means that my equation then is 4 times x squared minus 6x plus 9 times x squared minus 10x plus 34. The book, the directions say, write this in standard form. So they want you to multiply everything out and distribute to 4. If you get to this point, I'm really happy. Okay? Yes.
Before you substituted the 0 for x,
Yes.
why did you multiply those two?
Why didn't I multiply these two together? I could have. I just thought it'd be easier. But you can do that. Right. Anything else? All right, one more little thing here. See if I can find it. They're going to say, for what values of x is p of x equal to q of x? For what values of x are those two equal? So let's set them equal to one another. Then you go to your calculator. And in your calculator, into y1, you're going to put x cubed minus 5x. And into y2, you're going to put 0.5x to the fourth. And basically, you're going to look where do they cross. Go to your trace function. Put your cursor as close as you can to where they cross. And hit second trace. Scroll down to intersect. They're asking you for the first curve, you hit enter. They're asking you for the second curve, hit enter. They're asking you to guess, hit enter. And that's where they cross at negative 1.65. I want you to round to the nearest 100. Does it look like they cross somewhere else? Kind of looks like, you know what, I gotta go back to my trace, get that type of cursor. And it kind of looks like they cross here. So we do that again. Second trace, go down to intersect, and then enter, enter, enter. And it does intersect at 0. And this says if I put in 0 for x, these two will be equal to one another. If I put in negative 1.65, they will be equal to one another. All right, or pretty close. We approximated the negative 1.65. Okay. So your homework is on page 464. There's no test tomorrow. We're doing 34 through 50, the evens, and 52 and 53. And that'll give you about 10 problems. I'll finish up that section.